way back here, almost 2.5 years. You see, the sun didn't get the memo. You know, it didn't turn around real quick. In fact, it's going very inactive. It, last year, was free of sunspots for 73% of the time. This year, 79%. So it hasn't turned around yet. And the sunspots that do appear are very anemic. They don't persist long. They're very weak. This is a trend for the contrast between the sunspot itself and the surrounding sun. They're dark because they're cooler. Well, that contrast has been decreasing for quite some time, and this is from January of this year. If that continues, we could end up spotless, as we did in the Little Ice Age. Well, another way of looking at it, this is the magnetic field strength of sunspots. It's also decreasing. And here again from January, if that continues, so we've got two different markers that unless they change, we can see the sun is going to be much less active. Well, then we can look at the solar magnetic field. When it changes, it moderates the effect of the solar wind, which affects the Earth's cloud cover. This is very actively being pursued by some European scientists. They're going to do some tests in a large ion accelerator and see if they can come up with the exact mechanism. But in the 20th century, the solar magnetic field increased 2.3 times, not percent, 2.3 times, 230%. And that has now reversed. It's rapidly decreasing. So here's kind of a flow chart. If you have low magnetic field strength in the sun, we have fewer sunspots, we have less solar wind, get more galactic cosmic rays. See, the solar wind and magnetic field keep those rays from coming in. Now, as they increase, the theory is that they provide the nuclei around which low-level cloud droplets can form. And low-level clouds are very good reflectors of sunlight, so that would cool the Earth. So less solar activity, more clouds, cooler Earth seems to be what's happening. So we'll come to some conclusions here. Solar changes of the 20th century are sufficient to explain essentially all of the observed warming on Earth. Might be maybe 10% of it that might have been an effect of CO2 or something else. So far in the 21st century, solar activity is decreasing and the Earth is cooling. Now, where are we at? Well, anthropogenic global warming, the CO2 model that's got everybody up in arms and trying to change our entire lifestyle, it's not proven. CO2 does not appear to be the main driver. Rather, CO2 appears to change after climate has changed. The solar model, if it's correct, we're entering a major cooling phase. Now note this in red. That scares me. That scares me a lot. I don't worry about another degree or two of warming because history tells us that that's good. We did very well in that. Why does this scare me? Well, which model is going to prove correct? We got this grand experiment. CO2 model says we're going up. The sun says we're going down. Well, which will prove correct? What will benefit humanity? Well, let's look at history. Civilization has always flourished during the warm times. During medieval times, the warm time, we had castles, cathedrals, science developing all over Europe. Early on, the Roman Empire developed during the warm time. You go back 3,000 years, civilization really kicked off during the warm time. During the cold times, we suffered. Crop failures, starvation, plague. In the 1600s, population of Europe dropped by 1/3. Now look around you. 1 in 3 of you could disappear if that happened. That doesn't scare you, then you scare me. I would keep a close eye on what's going on with the crop production. Think of it this way. What if we had a really bad year and we lost the grain harvest in Canada? And this just at the time when we're turning a lot of our corn into fuel, which we don't need. Well, I don't know. What do you prefer? Are we going down the wrong road? I think we are. Well, summarize this, the CO2 model is flawed. Climate model projections are not precise. We don't have enough quality data even to go into them. Climate is certainly cyclical. We've got natural drivers. And we appear to have entered another cooling phase. On a positive note, I like to end on a positive note. I tell my students this. Are there any benefits to increasing carbon dioxide? Absolutely yes. What are they? This has been proven hundreds of times in experiments. Higher crop yields because plants require CO2. You give more of it, they do better. Not only that, but they use less water because the holes in the leaves that they breathe through get fewer and smaller with more CO2 and they lose less water. So, this could solve a couple of problems facing us. We'd have more food, use less fresh water, and plants are more resistant to problem times with more CO2. They do better in drought, they do better in cold, they do better all across the board. This, I sometimes think, could be providential, that we're heading into another severe cooling phase, and some of the people I talk with on a daily basis in our international discussion group saying, hey, we're already headed for a Dalton minimum, which was 2 centuries ago and it lasted a couple of decades. It was kind of nasty. Others say, well, we're already past that in solar activity. We could be heading for a Maunder, which lasted for 75 years. That's the Little Ice Age. So if that's correct, it appears that at least for some decades we're going to be cooling maybe the rest of the century. That scares me. It really, truly scares me. This could be providential because under those trying circumstances, the more CO2, plants might actually do better. For instance, greenhouses have been using air enriched with CO2 for decades. They go up about 11 or 1,200 parts per million. It's about 3 times what we have in the atmosphere. 10 years ago, I was giving a talk to the Rotary Club up in Little Falls, and somebody over said, hey, John, is that correct? Because, see, I had the local greenhouse owner in there. He said, yeah. They said, why? I said, well, the flowers are prettier. You know, plants do better. Okay, well, I don't know if we got time for the precautionary principle.
Running along here, maybe we should.
Okay, then I'll show you just 2 things. You've heard that the Arctic sea ice was disappearing, right? Well, we'll go to the next one, which is that bottom part. See here, this is for 2007, when we were melting a lot of ice. Turned out it was ocean currents that changed and blew the ice into warm water. When we were melting ice that took 7 years to produce. Now, how long is it going to take to replace 7-year ice? Well, you see, after 1 year, it come back some. Here, after 2 years, we're right back up into what's pretty much the norm. So this has happened before. It's not going to be any disaster. Thank you.